Hello students, and welcome to Genetics with Mrs. Klein. The topic of this video is incomplete dominance. You may recall from Mendel's law of dominance that one allele for a trait, the dominant allele, covers up other alleles, the recessive allele. But we're going to find out that this is not always the case, that genetics is not quite as simple as just dominant and recessive traits. Incomplete dominance occurs when neither allele for a trait is dominant over the other. You could say that both traits, in a way, are recessive. In snapdragons, for flower color, there are two alleles, a red allele and a white allele, but neither allele is completely dominant over the other. So, when you cross a homozygous red allele, big R, with a homozygous white allele, little r, all the offspring are heterozygous, little r and big R. But instead of looking just like the red parent, they are all pink, which is a mixture between the red and the white phenotypes. Incomplete dominance still uses the same three genotypes that we saw in traditional Mendelian inheritance: big R, little r, and little r. The difference is, compared to traditional Mendelian inheritance, which had two phenotypes, the dominant and the recessive, intermediate inheritance has three phenotypes: the big R for red, big R, little r, or heterozygous for pink, and little r, the homozygous for white. Let's try an example together. Let's cross a red flowered plant with a white flowered plant. Our red phenotype would be big R, and our white phenotype would be little r. In this case, all the boxes in our Punnett square would be heterozygous big R and little r. So if we go fill in our genotype and phenotype ratios, they are all big R, little r, 4 out of 4. And for phenotype ratios, they are all heterozygous, which would mean they show the intermediate trait, which would be pink. Let's do another example. Number 1B. We're going to cross a red plant with a pink plant. Remember, pink plants are heterozygous. In this case, our genotype ratio is going to be 2 out of 4 big R, and 2 out of 4 big R, little r. So for our phenotype ratios, big R means red, again 2 out of 4, and big R, little r means pink, also 2 out of 4. Let's try one more example together and cross two pink plants, in this case big R, and big R, little r. So this box will have big R, then big R, then big R and little r, and then 2 little r's. So if we go back into our genotype ratios, things in which case we have big R, which equals 1 out of 4. Big R, little r equals 2 out of 4, and little r equals 1 out of 4. For our phenotype ratios, our big R is going to give us red, which again is 1 out of 4. Our big R, little r, instead of giving red, it's going to give, remember, pink for 2 out of 4. And then little r, which will give us white for 1 out of 4. Now it's your turn to practice by yourself. Read the scenario on page 15 in your packet, and then work the problems 2A, 2B, 2C, and 2D. When you are finished, you may check your answers to see how you